In the field of science, the huge mysteries pertaining to what existed prior to the enormous explosion, the Big Bang, have sparked mixed conversations and fascinated thinkers for quite some time. This monumental question tests more than just our ability to decode the universe. It challenges the very boundaries of human knowledge. Imagine standing at the brink of existence, examining the colossus that is the universe, and pondering what may have existed before it was even imagined. The Big Bang established the beginning of all things, including time and space. But were you there a moment earlier? In the past, there may have been a state of nothingness, a calm before the cosmic gathering began. If this is accurate, was it truly nothing? Or was there perhaps something far more frightening that existed before the beginning of time? As we continue this inquiry, we are taken on a journey beyond the visible, guided by science and insight into the universe's origins, insight that tests our conscious awareness. Physicist Brian Cox is well known for his examination of the wonder of the universe. He suggests that something surprising may have existed prior to the massive explosion. His work directs us to reconsider our perception of reality and existence. In this investigation, we will dissect theories, review groundbreaking research, and uncover dazzling insider information that could help us figure out what happened before everything else. We will explore ideas like self-importance and cosmic growth, quantum alterations, dark energy, and multiverses. The answers may paralyze you, or they might open up new perspectives on our position in the cosmos. Prepare to plunge into the depths of the universe, into a realm that defies imagination and science. Amid the obscurity lie scientists whose theories were once left in the shadows. Some of these ideas shocked and even disturbed the scientific world. To investigate what preceded the Big Bang and the reasons for these theories, we must first meticulously examine what the Big Bang actually was. According to scientists, the Big Bang was the moment when the universe became extremely dense and hot, rapidly expanding and leading to the growth of all matter and energy. When we look at the night sky, we see no boundaries. The expansion of galaxies in all directions is evidence of this hot beginning. But why did this occur? Was there a time period prior to this blazingly fast start? The idea of massive expansion suggests that there was something before. Yet, it lacked any semblance of order. A state that was cold, empty, and unorganized, essentially resembling a vast vacuum. But this vacuum was not entirely devoid. It contained a tremendous amount of energy that fueled the rapid extension of space itself, known as inflation. This inflation occurred so quickly that it established the foundation for everything. It was part of a phase where space expanded at unimaginable rates, then slowed down, transforming energy into particles of matter and the forces we now observe. But what kind of energy was it? What purpose did it serve? Why did the universe suddenly expand? Experts propose that this immense expansion resulted in patches of the universe, each with its own properties. Imagine a fabric expanding after the Big Bang, forming tiny air pockets, each a different universe. This is the idea behind the inflationary multiverse, where there are conceivably endless Big Bangs and innumerable universes like ours. The concept challenges our perception of reality, leaving us with the question, what else is there? The idea that there was nothing before the Big Bang is speculative. Even if you removed all particles, energy, and radiation, the universe wouldn't be truly empty. Darkness fills the void with quantum fields and dark energy, forces that prevent complete emptiness. Understanding space itself means acknowledging its constants, rules, and properties that keep it from being truly void. Even in a vacuum devoid of particles or radiation, quantum fields and constants would still exist. This brings us to the concept of zero-point energy, the lowest possible energy state of quantum fields, where particles can temporarily appear and vanish, creating a subtle reverberation of motion. This challenges our idea of true emptiness. Indeed, there may have been a phenomenon prior to the Big Bang that scientists are only beginning to grasp. One of the most compelling cosmological theories today is the possibility of timeless inflation, suggesting that our universe may not be the first or the last. Brian Cox discusses astonishingly high levels of inflation, a multiverse where universes are infinitely produced and constantly expanding. Every Big Bang could be the beginning of a new universe, as different regions continue to inflate, birthing countless other realities. This idea leads us to the concept of a fractal universe, where each new universe might generate its own Big Bang. Each universe would be an independent domain, unaffected by others. This rapid growth of space suggests a multiverse with no defined beginning or end, an eternal cosmic structure that continuously constructs new universes. What if the unsettling truth is that there is no before or after, but only a timeless pattern of universal creation and decay? Quantum field theory supports this view. The universe is not merely a collection of matter traveling through space. It is a complex network of energy fields connecting everything. These fields are like invisible seas, with waves and particles appearing even at their lowest energy states. Even in a vacuum, particles can form and vanish. These are virtual particles, which cast doubt on the concept of absolute emptiness. Imagine a void universe with no matter, radiation, or energy. Would it be truly empty? Quantum field theory says no. Fields would still fluctuate, giving rise to transient particles and movement, even in the absence of anything tangible. This implies that the universe does not accept our notion of nothing. Fields and forces continue to exist, filling space with hidden energy. This knowledge prompts us to examine whether particles and matter themselves could have emerged from such a vacuum. Quantum fields, in conjunction with dark energy, the enigmatic force currently driving the accelerated expansion of our universe, may hold the answer. But was there dark energy before the Big Bang? Some theories suggest that dark energy, as we know it, is the remnant of an earlier field. The properties of dark energy may point to a vast and powerful force that managed the inflationary phase, leading to rapid expansion. Even in a universe devoid of matter and radiation, this force would persist, shaping space-time itself. This raises a troubling question. If dark energy existed before the Big Bang, could it have been the factor that triggered the birth of our universe? It's possible that dark energy is not just influencing our universe now, but also acted as the catalyst for inflation, or even marked the moment when our universe began. As we investigate this possibility, we face the notion that dark energy might be more than a current force. It could be the key to understanding the multiverse. Another theory, offering an alternative to the Big Bang as the ultimate origin, is the cyclic model of cosmology. In this view, the universe undergoes countless cycles of birth, death, and rebirth. The Big Bang, then, is not a singular event, but part of a timeless rhythm where universes expand, collapse, and regenerate endlessly. Revised and punctuated. Version: been reborn from the ashes of a previous life, the expansion and contraction of the universe. A cyclical pattern of expansion would entail that there was never a real start, but rather an endless series of universes, growing and changing cyclically, repeatedly. The study of cosmology raises significant issues concerning the notion that time itself may be cyclical, as opposed to linear. If this theory is correct, it could indicate that the preceding Big Bang was merely an additional version of a universe that burst open to give birth to what we have today. Researchers say that this theory offers many responses to questions of origins, claiming that there is no such thing as a single beginning. Since its inception, the universe has existed in some way other than our early concepts of time and existence. Waves of gravitation are another intriguing concept that may provide clues to what existed prior to the Big Bang. Gravitational waves are fluctuations in spacetime as a result of massive cosmic events. Scientific theories suggest that such waves, if ever found, might reveal new understandings of the universe's earliest moments. These waves might serve as the reminiscences of the past Big Bang. If they can be identified, they could provide evidence of the universe's previous cycles. The possibility of discovering gravitational waves in their early stages is one of the most intriguing opportunities in contemporary cosmology. It may not only expose truths regarding the Big Bang, but also offer a glimpse into the universe's state prior to the beginning of our own. This theory presents an enticing possibility, detecting gravitational waves that could serve as evidence of a universe preceding our own Big Bang. As we continue to investigate what might have existed before it, we explore ideas that challenge the limits of our understanding, putting even our most fundamental assumptions about space, time, and being itself at risk. Mind-boggling ideas emerge from the study of quantum gravity, which aims to unite general relativity and quantum mechanics. This merger may or may not reveal a theory of everything, a unified framework, and could offer insight into what existed before the quantum Big Bang. According to quantum gravity, time and space are not continuous, smooth entities as we experience them, but may instead be composed of hidden, granular structures. According to this theory, the fabric of space-time could have originated from a microscopic structure at the Planck scale, with tiny quantum fluctuations shaping the universe in ways we do not yet comprehend. What we perceive as a smooth space-time continuum may be a macroscopic illusion of these changing quantum fields. It's possible that time itself emerged from these fields, resulting in a reality where time and space, as we understand them, didn't yet exist. Another theory proposes that the universe is part of a vast cosmic landscape filled with potential universes, each with distinct physical characteristics. This string landscape theory, rooted in string theory, posits that all fundamental particles are actually tiny vibrating strings. Within this framework, numerous configurations exist, each representing a unique set of physical laws. The string landscape suggests that our universe is only one of many, each emerging from its own Big Bang-like event. These alternate universes might exist with different strengths of gravity, different numbers of dimensions, or even entirely different forms of matter. Our universe may not be unique, but instead, one part of a vast multiverse, each universe developing independently. The multiverse theory offers a hypothetical but intriguing answer to the question of what preceded the Big Bang. Perhaps another universe, arranged differently, led to endless cycles of development and destruction without a definitive origin. Physicists have also considered the role of black holes in cosmology. One hypothesis suggests that a black hole formed in an alternate universe could give rise to a new universe, ours. In this view, the singularity at the center of a black hole, where space-time curvature becomes infinite, might create conditions in which the laws of physics break down, allowing for the birth of a new cosmos. According to general relativity, the singularity could be the point from which our universe emerged, suggesting that the Big Bang was not the absolute beginning, but rather the consequence of a prior universe's collapse. Exploring these concepts requires a deep investigation into the nature of time itself. Some cosmologists believe that time, as we know it, may not have existed prior to the Big Bang. If true, then speaking of a before, the Big Bang becomes meaningless in any conventional sense. This perspective proposes that time itself might have emerged from quantum fluctuations or a primordial state in which the distinctions between past, present, and future did not yet exist. This leads us to reconsider causality, which depends on the idea of linear time. If events do not unfold in a straight line, if time itself did not exist, then asking what preceded the Big Bang may be absurd, as there would be no temporal framework to support the question. Theories of cyclic time suggest that the universe undergoes endless cycles of birth, development, and eventual demise. In this model, the Big Bang might simply represent the most recent oscillation in an eternal series of cosmic cycles. These cycles may differ in physical properties, but follow the same pattern: contraction, followed by expansion, again and again. This view renders the question, what happened before the Big Bang? Meaningless in the traditional sense, as each Big Bang is preceded by another cycle of collapse. The universe relaunches itself in a never-ending loop. Another line of inquiry considers that the cosmos originated from a primordial soup of bits and fields that existed prior to galaxy and star formation. This idea suggests that the universe existed long before its rapid inflation. It was filled with a hot, dense collection of elementary particles, quarks, leptons, bosons, in a high-energy state. At such extreme temperatures and densities, particles interacted constantly, establishing the conditions for the formation of matter and energy. Some versions of this theory propose that this primordial soup existed in a realm of quantum foam, where particles continually appeared and disappeared due to quantum uncertainty. Understanding the properties of this early quantum state could provide vital clues about the origins of the universe and what, if anything, came before the Big Bang. The question of what existed before the Big Bang remains one of the greatest mysteries in science. As quantum cosmology and fundamental physics progress, new hypotheses will continue to emerge, offering increasingly complex and sometimes paradoxical explanations of a universe our ancestors could hardly imagine. We may never fully understand what preceded the Big Bang, but the quest to find out will continue to push the boundaries of human curiosity, driving us to explore the outermost edges of knowledge and existence itself.